Howdy there, Internet students. Mr. Hermanson again. We're going to do lesson 2.1b. Basically, we're trying to figure out if we have equivalent ratios or which ratio is greater. So, and we're going to use percents to help us do that. So first of all, let's just get your opinion here. Below are two mixtures of how we're going to make some orange paint. We're going to take some red and mix it with some yellow and get some orange. Now what I'd like to know is which mixture do you think will be a darker orange, orangier, okay? So just pause, circle your choice, and then we'll discuss. I'll tell you what my choice is. Okay, so I chose mixture A and I went ahead and mixed it up there, and you can see I was right. It does make an orangier orange or a darker orange. Now, what makes a mixture darker? I'm going to say it this way. You guys probably have your own reasoning for this. I'm going to say it has a higher, hey, look at there, it's still that orange, the lighter orange, a higher percent of the darker color, the red. Okay, so whichever one has a higher percent of the darker color is going to be darker, right? Whichever has a higher percent of the lighter color is going to be lighter. Now, how can we use math to do this problem? Well, pretty simple. I can take this ratio here, which is 3 red to out of 4 total. So notice I said total here, so there's 4. This ratio is 3 out of 4 total. This ratio of red to total is 2 out of 3. So my 3/4, and I'm going to change that to a percent. Now I'm going to show you, since we're going to do this a lot, I'm going to show you a quick way to do the percent. Just do the 3 divided by 4. That gives you the decimal. And that decimal number is actually a percent, just by moving it over 2 places. So 75%. So this one is 75% red, and the other one is 2 out of 3. If I change that to a percent, I get 66 2/3%. So this one is 66 2/3% red. So that's how we're going to do it. So go ahead and try and figure out which of these is a darker orange by seeing what percent each one is of red. Go ahead and find those percents. My guess is you chose mixture D because it is 50% that dark red, where mixture C is only 40% that dark red. Okay, so now on 3, it says mixture F has more red than mixture E. Does that mean mixture F is darker? No, if it actually depends on what percent is red. So we're going to go ahead and figure these out. This one has 4 out of, you got to count them all, 7. 4 out of 7 red. This one has 6 out of 11 red. So go ahead and find the percents for each of those. Once again, the really quick way to do the percent is just do 4 divided by 7 and then move the decimal over 2 places. Okay, give that a shot. All right, so here's my answers. They're pretty darn close, aren't they? But I'm going to give it to E. It's a little bit higher, as shown by these percents. Notice I've been rounding to the nearest whole. Let's kind of do that unless I say otherwise for some reason. All right. So the researchers call this mixture Awesome Orange. Draw a picture to show how Awesome Orange can be created using 12 containers in all. Okay. So notice right now you have 4 containers making this mix, but we want 12. So we want the ratio to be the same as this ratio. So give that a shot. Well, to keep that same mix going, we need it to be proportional. So we have 3 out of 4 that are red, and instead we want that out of 12. So just solve this proportion. 4 times 3 is 12. 3 times 3 is 9. Basically, you need to take the number of red times 3. So you should have 9 of those. And the number of yellows times 3. All right. So we're going to complete this ratio table to show the number of red containers and the total number of containers for various batches of this shade. So the one I just did, we had 9 red. This is a new batch, sorry about that. So here we have 4 red, 2 yellow. So that's 4 red out of 6. That's this one right here. Now, if I wanted to make a smaller batch but keep it in the same ratio, I could just divide these 4 red by 2. So I have 2 red, and 2 yellow by 2 is 1 yellow. So I could have 2 red, 3 total. Okay, so notice this ratio, 2/3 is going to be consistent. So 2/3 equals, we're going to do this one now, 6 out of how many? And so this is tripled, so I'm going to triple this one and I get 9. Okay, now if I take 2 times 4, I get 8. That's this one. 3 times 4 would be 12. 2 times 5, so this one's times 5. This one was times 4. Times 5, 2 times 5 is 10. 3 times 5 is 15. On this one, we're multiplying this 3 times 30 to get 90. So 2 times 30 would be 60. Okay, I'm going to let you figure out the last one. Go ahead and pause it. If you did that right, you got 300. All right, so I showed you how to do that. So I'm going to let you do this one. Okay, now sometimes you're going to have some decimal numbers, but sometimes you could do that. You could have like half a bottle. There you go. All right, Soup and Salad Incorporated is catering a winter luncheon. According to the company, 8 cans of soup can feed 20 people. So that's this one right here. That means that, let's do half of that recipe. That means 10 cans, 10 people would need 4 cans. Okay? And then 2 people would need 5 cans. All right? And so I'm seeing a pattern here. Every time we add 5 cans, we need to, or 5 people, we need to add 2 cans, right? So I'll let you finish that up. So how many people will 2 cans of soup feed? 5. If Soup and Salad is planning to feed 25, how many cans of soup would they need? 10. Okay, now just so you know, you could take any of these ratios, like you could take this 5/2, and you could do the proportion thing also. So 25 people would go on top, and find that missing number right there, and you got it that way also. Okay, now if it's a ratio table, that means that all the fractions in the table, when you simplify them, you will get the same fraction. So, so like this first one here, if I take 6/10, I'm going to divide both those by 2. That's the greatest common factor, and that gives me 3/5, which is that one, right? And you got to check 9/15. I'm going to divide those by 3, the greatest common factor, and that's 3/5. So that's the same again, 3/5. So it's kind of looking, you might want to check one more, but it is looking like this ratio table can all be represented by the fraction 3/5. So These are pretty easy to tell they're equal to 1/2, right? If you simplify it, 4/8 is 1/2, 6/12 is 1/2, 8/16 is 1/2. The answer is, yeah. Oh, I just noticed something. I hope you guys did too. Let's go back here. So the first three were 3 out of 5, right? But I just noticed that this fraction right here, 12/18, the greatest common factor is 6. So let's divide those by 6. And that gives us 2/3. So that's 2/3. So we're going to say no because this ratio is not the same as these ratios. So it's not considered a ratio table. All right, so let's do one more problem, see how you do, and then that should do it for this lesson. So pick out which do you think is the darker orange and show your strategy. I was thinking that mixture Y is going to be the darker orange. It's going to be 60% orange. All right, that should do it here. You should be able to go ahead and do some of these problems, and we'll talk to you soon.